Hello, hello, hello. Welcome to a brand new week of Let's Learn Proofs at Home because, that sounds like fun. Squirrel is unfortunately asleep today, so she will not be joining us. I know she has very good questions, and she had a lot of questions on the advanced proofs one. So, because of Squirrel's numerous questions, we are definitely going to spend today, this would be Monday, doing Advanced Proofs 1. This would be practice number 1. Monday, Tuesday, Wednesday, Thursday, and Friday. Let's talk about what our plan is for this week. So, tomorrow I want to talk to you about quadrilaterals. We did a lab not so long ago, all about multiple choice questions. There are like 50 multiple choice questions, all about quadrilaterals. That's why we did that lab, and it's going to come into play. I wanted to do another lab this week just to help with that, but some of you are still struggling on how to get on Edmodo. So because you're still struggling on how to get to Edmodo, we're going to save the labs for next week. So we will not be doing labs this week. Next week we will start labs. After quadrilaterals, we're going to learn CPCTC. Very, very important. In fact, it's 2 days long. This one's going to be the advanced CPCTC. And then we are going to have advanced proof practice 2. We are following along in the package that was attached to our first video of advanced proofs. So without further ado, let's start with advanced proofs number 1 and talk about what you should have done. I gave this to you guys to try to see how far you would get without my help, because you will not have my help on the Regents. So we're going to take a look at this, and I'm going to go through it with you to make sure that you did it right, because if you can't do these things right, it's going to be very hard later on. Yes, it will be very hard, Squirrel. I'm sorry, did I wake you from your nap? Oh, I'm sorry. That was my bad. I was trying to be quiet. I wasn't trying to be quiet? Okay, I'm sorry. I thought I was trying to be quiet. Okay, fine then. Okay, so we have triangle AEG, that's the pink triangle, and triangle CFD. Yes, they're overlapping triangles. So what do we do, Squirrely? Whenever we have overlapping triangles, we must redraw the triangles separately. That is terrible redrawing skills. Okay, good enough. All right. Given measure angle A equals measure angle C, given, so that would be this angle up top. We have our top angles, so this would be A, G, E, and F, C, D. Okay. Second one, measure angle 3 equals measure angle 2. Now, if you notice, measure angle 3 and measure angle 2 are not in the triangles. If we look at the pink triangle, measure angle 3 is in the middle of the pink triangle. And it's on the outside of the blue triangle, and that's why we're going to need it. So measure angle 3 matches up with this measure angle 4 in my blue triangle. This is my blue triangle over here. So what we're going to say is we're going to say, how do we get angles inside a triangle? Linear pairs. Measure angle 3 plus measure angle 4 equals 180. Measure, that's not how we do measure. Measure angle 2 plus measure angle 1 equals 180. These are by linear pairs. Do one big sentence, measure angle 3 plus measure angle 4 equals measure angle 2 plus measure angle 1 by substitution. All right, now we know that 3 and 2 are the same. Because we know that 3 and 2 are the same, they can either both be 3's or both be 2's. I'm going to say that they should both be 3's, just for fun. Doesn't matter. Measure angle 4 stays the same, and measure angle 1 stays the same. Once they're both measure angle 3's, we can subtract off that measure angle 3. So this was a substitution. Substitution. And subtraction is the next one. So let's do measure angle 4 equals measure angle 1 by subtraction. And that means that this guy in here, sorry, this was 3, this one's 4, 2, 3, and this guy's 2. So 3 was this, 4 is going to be 3. Then E is where 2 was, and this is where 1 is, so that's going to be 3 there. So many angles are equal to each other, but not equal to anything else. Good grief. Okay. Oh, good, we have some sides. That's exciting. So we go on to the sides. GF is equal to ED. That's given. GF equals ED. And that's unfortunate because that is not a side. I would need GE, not GF. And I would need FD, not ED. So we're going to need to add on FE to both of those. So I'm going to say FE equals FE by reflexive. So that means GF plus FE, and then I want to take ED and I want to add FE. That's called addition. And I want to do that to get GE and FD. So GE now equals FD by side addition. Okay, so that means this side and this side. 2, 3, 1, 2, 3, 2, 3. That would be angle, angle, side. Notice the side is not trapped between my two angles. Because the side is not trapped between my two angles, it's going to be angle, angle, side, also known as side, angle, angle. Either one of those would work. Just remember, it is not angle, side, angle. No, because the side isn't trapped, squirrel. You can only use side, angle, side if it's trapped. So angle, angle, side, or side, angle, angle. Either one would work. No, either one would work, squirrel. They're the same thing. So that would be triangle AEG congruent to triangle CFE. Yep, that's how we do it. That was not that bad. It was not that bad. You're just complaining. You complain a lot. Okay, next one. Statement reason. Take a look at our pink triangle, AEG, and guess what? CFD, just like before. This is going to be exactly like before, but is it? Why would I put 2 of the exact same thing on this? Oh, it's not ink tissue. This is FCD, and this is AGE. Let's take a look. The first given is exactly the same. The first given's exactly the same. AC, A and C. So A and C, A and C. So measure angle A equals measure angle C by given. Okay. Second one is 3 and 2 are the same. Well, if 3 and 2 are the same, that means 1 and 4 are going to be the same by doing this again. Okay. So far, I have not changed anything. Next one, we've got AB equals BC. Okay, now we've got some differences. So AB equals BC. AB equals BC. Oh, that's up top there. And that is not, so we're trying to look at this side. This time, they are trying to capture that side between the angles. But they've only given us part of that side. The next given is BE equals BF. So we're going to have to add those two pieces in order to get the side trapped between my two angles. So BE equals BF. These both are given. I want to take AB and be very careful when we talk about what we want to add to AB. A lot of people say AB plus BF. Well, no, I do not want to go AB plus BF. That's not going to get me the side right here. I want to go AB plus BE. So AB plus BE, and then BC plus the one that's left is BF. That's addition. And that gets us AE and CF. So AE equals CF by side addition. And then we get side angle, side angle. Because the side is now trapped right here between my two angles. And that's going to be prove triangle AEG is congruent to triangle CFD. So that's how we do the front of our advanced proofs. Notice they were very similar, so be very careful. They look the same, they act almost the same, but they're two very different proofs from the green line down. From the green line down, they're very, very different. From the green line up, they're exactly the same. Okay, let's take a look at our circles. Yay, circles. All right. Statement reason. Good news. Only two triangles in there, so it's got to be ABD, and it's got to be CBD. Look at that. Okay. BD is a diameter. Given. Uh-oh. Diameter means the next thing has to be definition of diameter. And the definition of diameter is the circle, so sector. Yeah, we call it a sector, squirrel. Sector means the area of a circle. Yeah. The sector BAD and sector BCD are semicircles. And then, of course, over here, we need definition of semicircles. The definition of semicircle is just half a circle. That's not helpful. What is helpful is if we use one of those rules that involves semicircles. Yeah, it's the first rule on our circle list. The first rule on our circle list is angles inscribed in a semicircle are 90 degrees. Good job, Squirrely. They're right angles, 90 degrees. So that means that measure angle A and measure angle C are 90 degrees. So measure angle A equals measure angle C equals 90 degrees. Yes, they're right angles. That doesn't necessarily mean it's hypotenuse leg. Yes, this one is going to be hypotenuse leg, but we haven't gotten there yet, Squirrel. You got to calm down. Yeah, we got to use our next given. Our next given is AB equals DC. Given AB equals DC, yes, and then we have a reflexive. BD equals BD by reflexive. Remember, what do we need when we got rid of all of our givens? Reflexive, and what else could we have? Remember? Vertical angles is the other one, Squirrel. Vertical angles. Yeah, you got to remember that. Okay, so that means hypotenuse leg. So we're going to go with the hypotenuse leg. Triangle ABD is congruent to triangle CBD. And if you did that, you did it wrong. Oh no! You can never go automatically to hypotenuse leg. You must always have the step before it. Triangle ABD and triangle CBD are right triangles. We know that because of the 90-degree angles. From right up here. Very careful. Never forget this step. We went over it on this problem when we did it in the practice. So be very careful on that. All right, number 4. Statement reason. Given AB equals DC. Given AB equals DC. Okay. And then we have the next one, vertical angles, because we've run out of givens. So measure angle AEB equals measure angle DEC. Vertical angles are congruent. And we've run out of givens. We have no reflexive. We've run out of vertical angles. So now we have to go just based on the picture. If you remember, this one's almost exactly the same as the one we went over in the notes. So triangle ABE, similar to triangle DCE. Why are they similar? Why would those two be similar triangles? For that, we have to go all the way back up here. Triangles formed by intersecting chords are similar triangles. Yeah, that's one of the things you're just going to have to learn. Triangles formed by intersecting chords are similar. And we've got similar, which automatically means we're going to need a definition of similar. Sorry. We've got similar right here. Let's do it in the right color. We've got similar. That's a vocabulary word, so this needs to be definition of similar. Definition of similar is angles are the same. So we can choose either A and D match or B and C match. I'm going to go with B and C this time. So measure angle B equals measure angle C. Definition of similar, It's angle preserving. So that gives me angle, angle, side for my two triangles. Triangle ABE congruent to triangle DCE. So that's what the first two look like, number 3 and number 4. Let's take a look at number 5 and number 6. Number 5, we've got radius to tangent. That's very important. Statement reason, BD is radius, and AC is tangent. These two are given. AC and BD then need to form right angles. And how do we write that? How do we take radius plus tangent? We can't just say definition of radius and tangent. I really wish we could. It'd be so much easier if we could just do radius plus tangent equals 90. Because to be fair, that's what's happening. Now we have to go all the way back up. And if you look at this one in the homework, angles where diameter and tangent meet are 90 degrees. So we go down here, angles where radius and tangent meet are 90 degrees. So that would be measure angle BDC is equal to measure angle BDA equals 90 degrees. So this angle here and this angle here. And most of you are saying, oh, we've got right angles, it's going to be NHL. Funny story on this. We've got AD and DC. AD equals DC is our next given. That's AD and that's DC. We've run out of givens, which means either vertical angles or reflexive. BD is going to be my reflexive. Which means this is not going to be HL. We don't have the hypotenuse. If we don't have the hypotenuse, we can't have HL. HL is literally hypotenuse leg. So in this case, we're going to have to go with side, angle, side. And notice the angle is wedged between my sides. The angle is trapped, so it's going to be side, angle, side. Triangle ABD congruent to triangle CBD. All right, so that's how we do number 5. Number 6. Statement reason. BD is diameter. ADC is tangent. That's going to be my givens. And just like before, we've got diameter and tangent. Well, a diameter is just an extended version of a radius. So because a diameter is just an extended version of the radius, we're still going to do what we did over here. So it's going to be angles where you could either say where radius and tangent meet or where diameter and tangent meet. And tangent meet are 90 degrees. And so my 90-degree angles are going to be right here and right here. So measure angle BDA is the same as measure angle BDC equals 90 degrees. Next given, ABC is isosceles. Triangle ABC is isosceles. Okay, so let's take a look at ABC. ABC is the big triangle. That's isosceles. So we're going to write given. And of course, since we've got isosceles, the next thing that we need to do is definition of isosceles. And as many of you have come to learn, there are two definitions of isosceles. First definition of isosceles is the sides being the same. So AB is going to be equal to BC. The second definition of isosceles is those angles are going to be the same. So measure angle A equals measure angle C. At that point, you can say side angle angle. Some of you automatically saw we've got a reflexive down there. So you could do BD is equal to BD by reflexive. If you saw the reflexive, you can do it for the angle side this way, going up here, or you can do angle side going this way. Notice it doesn't change what you have in this case. In this case, you're going to do it with angle side regardless because you don't have this angle up here or this side down here. So you don't have an angle trapped between sides and you don't have a side trapped between angles. So it's going to be angle side regardless of what you do. Unless you decide to do angle side. Angle side is illegal, right? But we've got a right angle. Because we have a right angle, we could do hypotenuse leg if we wanted to. That is, of course, more work. I'm lazy and I don't want to do it. Yeah, I'm lazy, squirrel. We're not going to do it that way. I'm just going to say triangle ADB is congruent to triangle CDB by angle side. As I said, you could prove it by HL. If you do prove by HL, that's perfectly fine. Just remember your extra step. A lot of people forget that extra step. But we have the 90 degrees right there, so it's perfectly fine. Now, what I want you to do, I want you to go through your proofs. Make sure you've done these correctly. What you're going to do is you're going to hang on to this worksheet. You're not going to turn it in until the end of the unit. The end of the unit, we are going to turn in practice number 1, practice number 2, that we are going to be doing on Friday, and practice number 3 that we're going to be doing next week. Practice 1, 2, and 3 are going to be a nice, cute little packet that you are going to hand in. Now, some of practice 2 I will do with you, but I'm not going to do all of advanced practice 2, just like I did advanced practice 1. I want you to try and do more of the practice 2, and then I'm going to do very little of the practice 3. We're going to try and wean you off of this. But for advanced practice 1, since this was your first nosedive into advanced proofs, I decided to do all of the advanced proofs practice 1. So take a look at it. Once again, you do not need to hand it in until I tell you to hand it in. And I will tell you when I want it. And if you don't hand it in, I will hound you until you do. Thank you very much for this wonderful episode of Izzo Teaching Squirrel Advanced Proofs. Tune in tomorrow for another stellar round.